Florencio de los Santos here. Let's talk about the third law of thermodynamics.
He does know about a lot of stuff, Florencio JUN explains.
The third law of thermodynamics deals with another strange concept, the idea of temperature of absolute zero. We know that temperature can get very high and very cold, but not everyone is familiar with the idea of the coldest possible temperature. However, with our new understanding of heat and temperature, it should make perfect sense. We know that temperature is a measure of available heat energy, which is just collection of kinetic energies of motion. We know that as temperature decreases, the internal energy of the system decreases as the kinetic energy of each particle. As the temperature becomes very cold, particles slow to a complete stop, and there is no more kinetic energy. No more kinetic energy of motion means no more temperature by any real definition of the term. So we'll call this absolute zero. At absolute zero, every substance would be a solid, even things like hydrogen and helium. And one way of summarizing the third law of thermodynamics is by saying that the entropy of any crystalline substance at an absolute zero will be equal to zero. This is a necessary consequence of Boltzmann equation. S is equal to K times the natural log of W. If there is no kinetic energy, nothing is moving, so there is only one possible microstate that the particle can inhabit, with the value for W equal to 1. The natural log of 1 is equals to 0, so at absolute 0, the entropy of any substance must also be 0. However, absolute 0 can never be truly rich, which is communicated in a rephrasing of the third law, which states that it is impossible to lower the temperature of any system to absolute 0 in a finite number of steps, as a satisfactory analysis of this law will require the quantum mechanical zero-point energy. This concludes our analysis of the third law of thermodynamics, a near mythical accomplishment in the history of science. Now, we can move on to other things, but first, let's check comprehension. Thanks for watching, classmates!